Welcome to today's deep dive. I'm your host, and today we are looking at this really fascinating document from the Dryer Vent Safety Council. We're going to explore the hidden physics happening inside your laundry room right now.
Yeah, we're focusing on this concept called back pressure.
Right, back pressure. And I mean, while that might sound like this super dry technical engineering term, it is actually a brilliant lesson in how we measure the invisible forces in our everyday lives.
It really is. It changes how you look at your whole house.
It does. So, okay, let's unpack this. Because to really understand what this document is telling us, we kind of have to rethink what a dryer actually is in the first place.
Yeah, because we are so accustomed to viewing home appliances as just these simple, single-purpose boxes. You put wet clothes in, you get dry clothes out.
Right, and you just assume the heat is doing all the heavy lifting.
Exactly. The assumption is that the heat does the work, but the heat is only half the equation, really. A clothes dryer is, fundamentally, a massive air pump.
An air pump?
Yeah. It takes in ambient air, heats it, absorbs the moisture from your clothes, and this is the hard part, it has to push that heavy, wet air out of the machine through the entire length of the exhaust system and safely outside your house.
And that exhaust journey is, like, completely hidden from us. We don't see the air traveling through the floorboards or, snaking up into the attic.
Right. It's totally out of sight. But that ductwork acts as a physical barrier to the airflow. So the technical term for the resistance the dryer is fighting against is back pressure or static pressure.
Okay, static pressure.
Yeah. As the dryer tries to expel the air, the walls of the vent, the length of the pipe, the bends in the system, all of that pushes back against the airflow. So back pressure testing is just the process of putting a numerical value on that invisible struggle.
And the document uses a very specific metric to quantify this resistance, which it's called inches of water column, which to a layperson like me, measuring air resistance in inches of water sounds completely nonsensical.
I know, it sounds super obscure, but it's actually incredibly literal.
Wait, really?
Yeah. Imagine a clear U-shaped glass tube, right? And it's filled halfway with water.
Okay, I'm picturing it.
If you attach a hose to one end of that U-tube and blow into it, the air pressure pushes the water down on your side and the water level naturally rises on the other side.
Oh, sure. Basic displacement.
Exactly. So the amount of force required to push that water level up exactly 1 inch is 1 inch of water column. It is this highly sensitive unit of measurement designed specifically to track very, very small pressure differences.
Differences that, like, standard gauges just wouldn't even register.
Right. Standard gauges would just read 0. They aren't sensitive enough.
That makes total sense now. But, going back to the ductwork, I always assumed engineers would need to pump some kind of, specialized tracer fluid or colored smoke into the walls to see how restricted it is, like blowing into the crazy straw.
Yeah, that would be the assumption.
But the source points out this much more elegant solution. We don't actually need a special test medium, because the appliance itself is already a heavy-duty fan. We just let the dryer run and use its own standard operating output to test the resistance of the pipes.
Which is just, well, it's a beautiful example of practical engineering. The machine is already doing the work for you.
Right.
It is pushing a consistent volume of air into the ductwork. By taking a measurement of how hard that specific machine is straining against that specific duct system, you capture this unique fingerprint of the home's exhaust resistance.
You are basically taking something completely invisible, the friction of air against metal, and turning it into actionable data.
Exactly. You're giving a number to the invisible.
Which brings up a huge point, because as a homeowner, I always assumed my dryer was just, fighting against the lint-clogged filter. Whenever someone mentions a dryer vent issue, lint is just the immediate villain.
Right. Everybody blames the lint.
But looking at these sources, lint is just the tip of the iceberg. The document is very careful to correct that misconception. It really emphasizes that resistance is cumulative.
It is. I mean, lint accumulation is certainly a factor, but the document highlights several structural issues that often contribute far more to the overall back pressure.
Like what?
Well, one of the primary culprits is what engineers call effective length.
Effective length.
Yeah. So if your laundry room is right in the center of the house, the sheer distance the air has to travel to reach the outside wall that acts as a massive physical barrier. Air loses momentum the further it travels.
Okay, so just the long pipe itself is exhausting for the machine. And the text also talks about elbows. So taking that crazy straw analogy further, every time the ductwork has to make a 90-degree turn to, like, get around a floor joist or snake up into a ceiling, it creates a massive spike in back pressure.
Oh, absolutely. The physics of an elbow joint are actually quite violent at a microscopic level.
Violent? Really?
Yeah, because the air isn't just smoothly curving around a corner like a race car on a track. It is literally slamming into the metal wall of the duct, creating this vortex of turbulence.
Oh, wow.
And that turbulence acts exactly like a traffic jam, causing all the air behind it to slow down and back up.
That is a crazy visual, just air piling up inside the wall.
Right. And on top of elbows, you might have ductwork hidden behind the drywall that was accidentally crushed during construction. Or you might have an exterior termination flap, the vent cover on the outside of the house.
Oh, yeah, those little plastic louvers.
Exactly. Those can get painted shut by accident or totally blocked by a bird's nest.
Which I've actually seen happen. But the consequences of that traffic jam are what make this so dangerous, right? Because if the air slows down due to a crushed pipe or too many elbows, the moisture suspended in that hot air, it cools down before it can actually escape the house.
Right. And that is the true hidden danger of elevated back pressure. Because when that vapor cools, it condenses back into liquid water right inside your walls.
Yikes.
Yeah. And that water catches the stray lint fibers that bypass the filter, creating this wet, heavy papier-mâché-like paste that just coats the inside of the duct.
Oh, that sounds awful.
It is, because that paste narrows the pipe, which creates more friction, which then increases the back pressure even further. It is this vicious cycle that forces the machine to run hotter and longer.
Which wastes electricity.
Yes, wastes electricity, wears out the appliance's motor prematurely, and eventually it creates the perfect conditions for a devastating house fire.
But wait, here's a detail from the text that I thought was super interesting. Even if the pressure is high, the test still doesn't tell us what the blockage actually is, right? Like the tool doesn't display an error code saying, hey, you have a bird's nest. It just gives you the total inches of water column.
Right. And this raises an important point about how we diagnose household systems. The source draws this really profound philosophical distinction here. The measurement identifies the performance condition, but it is the professional inspection that identifies the cause.
It's kind of like going to the doctor with a fever, The thermometer tells you your temperature is 102 degrees.
Right. Perfect analogy.
That physical measurement proves there is a condition that requires attention. But the thermometer doesn't tell you if you have, like, a common cold, the flu, or some serious infection. The doctor has to use their actual expertise to conduct the inspection and figure out the why.
And the vent technician operates the exact same way. They measure the cumulative resistance first, just to establish that the system is quote-unquote sick, and then the diagnostic work begins to uncover the structural issues or blockages that are responsible.
Okay, so to get that pristine baseline measurement, the dryer vent safety...
Right, which sounds very sci-fi.
It does. Piezoresistive. But basically, when the air pressure pushes against that chip, it actually bends the silicon just enough to change its electrical resistance. And the device measures that tiny change in electricity and translates it into a precise digital number on the screen.
Exactly. Both instruments answer the exact same fundamental question, but they require a very specific setup. The technician cannot just, wave the tool around the laundry room.
So drill a small hole.
Yes. A small hole is drilled, and a test probe is inserted directly into the exhaust duct within 12 inches of the dryer outlet.
Why so close to the dryer?
That placement is critical because it captures the total pushback of the entire house's ductwork right at the source, before the air even begins its journey.
Gotcha. Now here's where it gets really interesting for me, looking at the testing protocol. The DVSC specifies that you have to run the dryer empty, with a clean lint screen and on air only, as in absolutely no heat.
Right, cold air.
Which feels incredibly counterintuitive. I mean, heat is the whole point of the machine. Why on earth would you remove its primary function to test its performance?
It's a great question. It all comes down to the thermodynamics of air. When you introduce heat into an enclosed space, you totally change the behavior of the air molecules.
Because they get energized.
Exactly. The heat gives them kinetic energy, so they move faster and try to spread out. That thermal expansion creates its own internal pressure variations.
Ah, so the heat acts as like a rogue variable in the test.
Precisely. By running the dryer cold, you completely eliminate the variable of thermal expansion. The air density remains constant. That guarantees that the measurement on your manometer is a pristine, uncorrupted reflection of just the physical geometry of the ductwork, the length, the elbows, the lint, the crushed sections.
This is purely structural.
Right. And because there is no fluctuating heat to skew the data, that exact same baseline condition can be perfectly replicated later to verify if a repair actually worked.
Okay, but a scientifically pristine number is fantastic for an engineer, right? But for a regular property owner who's just staring at a technician, being told, hey, your vent is running at 1.4 inches of water column, I mean, that means absolute nothing to me.
No, it's total gibberish to most people. But the Dryer Vent Safety Council accounts for that knowledge gap. They translate all that raw data into a universal traffic-light classification system. It bridges the communication gap effortlessly.
Which I love because it really empowers you as the homeowner. So green is obviously the optimal flow zone. Generally, this means the pressure is exceptionally low, indicating the system is highly efficient and the air is escaping with minimal friction.
Right, green is great. Yellow indicates an acceptable range, but it serves as a warning.
Like a caution light.
Exactly. The system is functioning, but the back pressure is elevated. The dryer is working harder than it should have to, likely due to suboptimal duct design, a long effective length, or maybe some minor buildup.
And then red is the critical zone.
Mm-hmm.
The restriction is so severe that the appliance is actively suffering and the risk of catastrophic failure or, a fire is imminent. It warrants immediate intervention. But the text includes a really critical warning here that I want to highlight.
Oh, about what red means.
Yeah, a red light does not automatically mean clean the vent.
And that is a deeply ingrained habit the industry is actively trying to break, because back pressure measures performance, not cleanliness.
Right.
If the technician assumes a red reading just means they need to run a brush through the pipe, they might remove a handful of lint, sure, but they will completely ignore the crushed ductwork inside the ceiling, and the system will just remain in the red.
Wow.
So the classification dictates that the technician must evaluate the system and use their professional judgment to diagnose the actual root cause of the resistance.
And because you can't physically see the crushed pipe in the wall, how do you even know the technician actually fixed it? Which brings up probably the most practical takeaway from this entire document, the before and after measurement.
Yes, because historically, vent cleaning has relied entirely on trust.
Totally.
A technician runs a brush into the wall, pulls out some lint, packs up their tools, and assures the homeowner, hey, the airflow is better. But the homeowner has literally no way to verify that claim.
Not at all. There's a great quote in the source from David Lavelle. He's the co-founder of the Dryer Vent Safety Council that perfectly summarizes their philosophy on this. He says, and I quote, "What's not measured cannot be managed."
It's so true. By measuring the system under those strict, cold, empty conditions before the service, the technician establishes an undeniable starting condition.
Right.
So let's say the manometer reads 1.6 inches of water column. That is solidly in the red. The technician then goes to work. They pull out the lint, but during their inspection, they also discover and replace a kinked transition hose hidden right behind the dryer.
Okay.
When they finish all that, they run the exact same cold air test.
And the gauge drops to, say, 0.4 inches of water column. You are suddenly in the green. So you aren't just relying on this vague impression of airflow anymore. You have hard, physical proof that the hidden infrastructure of your home has been fundamentally improved.
Exactly. And it also serves as a crucial check for the technician themselves.
How so?
Well, suppose the initial measurement is in the red. The technician clears out a massive bird's nest from the exterior flap. They run the second measurement, fully expecting a perfect score, but the gauge shows the system is still sitting in the yellow.
Ah, so the bird's nest was only part of the problem.
Right. The improvement is valuable, sure, but the lingering yellow status tells the technician that their job is not finished. The diagnostic process has to continue. Perhaps there is an unnecessary 90-degree elbow buried in the attic that needs to be rerouted. The data prevents the dangerous assumption that performing a single service automatically equates to optimal performance.
This shifts the entire perspective of home maintenance, honestly. We are moving away from treating appliance care as this subjective chore and treating it as a measurable science. And this shift is happening across the entire appliance industry.
It really is. Dryer manufacturers have long recognized exhaust system resistance as the ultimate bottleneck for their products.
Because they can build a great machine.
But they design machines capable of incredible efficiency, and if the home's infrastructure is poor, the machine fails anyway. The dryer's internal computer does not have eyes. It doesn't know if the resistance it's fighting comes from a lint clog or a crushed pipe. It only registers the total back pressure.
Right.
So by standardizing how we measure that resistance in the field, technicians can actually ensure the home environment meets the manufacturer's strict operational requirements.
Yeah, the document quotes Tim Royer on this. He's a 20-year veteran of the industry and a certification trainer. He calls back pressure testing the gold standard for measuring dryer vent performance.
He's absolutely right.
His quote really captures the essence of this whole paradigm shift. He says, "I love the science of the industry. Anyone can clean a dryer vent, but professionals know how to properly diagnose and test."
What's really fascinating here is how it completely reframes the core question that property owners ask. For decades, the standard question has just been, is the dryer vent clean? Which, implies a binary state of either dirty or spotless.
Yeah, clean or not clean.
Right.
But the much more vital question we should be asking is, how is the dryer exhaust system performing?
Exactly. And instruments like the analog gauge and the digital manometer, they provide the raw data to answer that question. But no instrument replaces the human element. The measurement tells us how the system is performing. The human professional determines why. It is this perfect synthesis of scientific data and diagnostic expertise.
So what does this all mean? It means that making the invisible visible through consistent, rigorous data completely changes how we manage our environments. We take a hidden struggle, literally air fighting its way through a maze of metal. We capture it as a concrete number.
A tangible metric.
Right, we translate that number into a simple color code. And we use that color code to make informed, verifiable decisions that protect our appliances, our homes, and our safety. Understanding this doesn't just make you a smarter homeowner who knows the critical difference between cleaning and diagnosing. It shows how applying a little bit of scientific measurement to the hidden corners of your life can give you absolute clarity.
And, we spent this time exploring how capturing the invisible back pressure behind your drywall changes everything about how you maintain a single appliance. It really makes you wonder what other systems in your home, your work, or even your daily routines are quietly fighting a losing battle against invisible cumulative resistance, simply because you've never thought to measure the back pressure.
Oh, that is a perfect thought to leave on. Thank you so much for joining us on this deep dive into the hidden physics of your home. We'll catch you next time.